This is Daniel Coosbury, and in this lecture, we're going to look at what's kind of the realm of business math or personal finance. And so this section focuses on percent increase and sales tax and discounts and just things that you might encounter in everyday life. And this might be a lot of stuff you've done already, but we're going to kind of look at some common threads that run through these problems and kind of see how similar they are and kind of gain some skills as we work on them. So before we do, we need to talk about percentages, and so we have we're going to need to convert some of our regular numbers to percents and vice versa. So we often represent fractions and decimals as percentages and vice versa, and so the little kind of the nuances in changing them from one to the other are a little bit tricky. So here's the steps to converting a fraction to a percent. We're going to start by dividing the numerator by the denominator, and then we're going to multiply the quotient by 100 so as to make that a true percent. And so we're just going to treat this 3/8 as a regular division problem. I'm going to give myself a little bit more room. A regular division problem where we're going to do 3 divided by 8, and I'm going to do it the long division way. Okay, so I'm going to do 3 divided by 8. Notice this number is smaller than the 8, so I'm going to have to put a little decimal there and a 0, and now I can do the regular old long division where I'll see, okay, 8 goes into 30 3 times, and I get 24 here. And then if I bring this up, another 0 down, I have a 60 here, and 8 goes into 60 77 times. And I get a 56 here. I think I can do this one more time. 8 goes into 40 5 times, and that leaves me a remainder of 0. So when I do that, 3 divided by 8, I get 0.375. So this is simply converting that fraction to a decimal. And then I want to multiply that quotient by 100. So I'll move that decimal over 2 places to the right, and my percent ends up being 37.5%. So that's how I do that. So essentially it's converting the fraction to a decimal and then moving the decimal over to make it a percent. And it's really not much more than that. So a simpler problem would be converting decimals to percent, which if it's already a decimal, I can just take this decimal, move it over 2 places, and make it a percent like that. So this would be 3.5%. So it's a pretty simple conversion. So that's kind of where percents come from. And then if we want to express percents as decimals, that's also just as simple. We want to take the decimal, and this time we would divide this number by 100. So if the decimal's here, we'd move it back 2 places. This would be 0.41. So that's what that is equal to. They're the exact same number. And we could do the same thing here. There's a little decimal here right after the 107. We move the decimal back 2 places. This becomes 1.07 as a decimal itself. So what we're going to have to do is when we see percentages and we see decimals, we're going to have to start distinguishing between which one is which. So when we see no percent sign around this, we can look at this and say, oh, well, this is just 41%, even though it doesn't look like a percent right now. So that's not a terrible thing to do. It's just mostly moving the decimal back and forth. The heart and soul of this section is this formula right here. And this is just kind of how we would talk about percentages. So if we were to say that something is a certain percent of another thing, so we could say A is a certain percent of B, or P percent of B. When we would say percent of, we're going to think of that as a multiplication problem. So some percent of something else, we're actually going to have to multiply that percent rate. And this section is going to be like a tax rate or a discount rate or things like that. We're going to do some multiplication to make that happen. So converting word problems into percent problems is not that hard. We're going to interpret is as an equal sign, of as a multiplication sign, and then everything else is going to go where it is. So one consequence of just reading this is we have a nice little formula for sales tax amount. So if we wanted to calculate the sales tax on a certain item, all we would need is the tax rate and then the cost of the item. If we have those two things, we can multiply them together and to get the actual tax. So here's an example where we want to purchase a new car. Here's the price of the new car, and here's the sales tax. And so this first question asks, well, what's the sales tax on the new car? So according to this formula, all we need is the tax rate, which is right here, the 7.2%, and the cost of the car, which is this $21,000. and we can calculate the tax. So our sales tax is going to be equal to, let's see, the tax rate is 7.2%. However, when we use this in our calculations, we need to convert this percent to a decimal. This needs to become a decimal. So we're going to write this as 0.072. We're going to move the decimal back 2 places. And that's going to be the number we end up doing our calculations with. So we're going to be doing 0.072 as our tax rate times the item cost, which is $21,000. And this will tell us how much tax is on that item. So I'm going to do the multiplication in my calculator. 72 times 21,000. And I get 1,512. So that's the tax. Okay, so that's how much will be added to the cost of this car when we actually buy it. We'll call it the tax. And so probably a more interesting question is, how much are we actually going to have to pay for this car? So if we consider we're going to pay this original price, this $21,000, plus the tax, which is $1,512, then this ends up being $22,512. So this problem turned out to be 2 steps because calculating the sales tax amount was only one part of the problem. Getting the entire price of the car was the whole problem. We would just add that tax amount to the original price. Okay, here's another context. So you'll notice this this formula looks a lot like the sales tax formula. We're just using this A is P% of B scheme in these sort of problems. So imagine you're at a store and there's something on sale for maybe 30% off, and that percent off we're also going to think about as a rate, kind of like this B here. In the last example, this tax rate was our percent, this 7.2 was our rate, and in a case of a sale or a discount or something, that discount rate is going to be our percent. So the problem works in a very, very similar way, even though we're just giving new names to things. In the last problem, we called these things taxes. Here, we're just going to call it a discount amount and a discount rate, as opposed to the sales tax amount and the sales tax rate. The problem works the exact same way. Okay, so here we have a dress on sale for 30% off. So there's the discount rate. And here's the original price of the dress. And the question is divided into 2 parts again. So the first part is, what is the discount you will receive when you buy this dress? So we're going to find the discount amount. Here's the rate. We want the actual amount. So how much money are you going to save is another way of phrasing this question. So I'm going to say that my discount is equal to the discount rate. So here's the 30%. I need to write this as a decimal. That's 0.30. The 0.30 times the original price, which is $149.95. Now maybe you've been dress shopping enough to know already what's 30% of $149.95, but I haven't done this very much, so I'm going to do this on my calculator real quick, and I end up with 44.985, and I'm just going to leave it like that. And so that's the amount of discount. Notice this is not a real nice dollar figure because we got a third decimal, but we'll clean that up when we write our final answer. So then the question that's more interesting is, how much are we going to pay for this dress? Okay, so if I'm dress shopping, I'm going to pay this original amount minus any sort of discount I get from the sale, which I already counted the discount. It's 0.985. So I'll do some simple subtraction here. And I get $104 and some change, 0.965. I'm just going to round up to 0.97 because that makes more sense in context. Because my calculator said 965. I'm just going to round that up because that little third decimal doesn't mean anything when we're talking about money. So there's our actual price. The 30% off of $149.95 is $104.97. So that's what we're actually going to pay. Otherwise, this worked exactly the same as the tax problem. Tax problem, we calculated the tax first, and then we had to add that on. The discount problem, we calculated the discount first, and we just subtracted it because it's a discount. This other type of problem in this section is going to be called finding the percent increase or decrease, a percent decrease. So imagine a situation where something is changing over time And we're not really interested as much in how much did it change by, but we're interested in what percent, or by what percent did it change by. And so we have this formula here for a percent increase and decrease. The percent increase is going to be the amount of increase, so how much it increased by, divided by the original amount, and then the same for the decrease. So if something decreases over time, it'll be the amount of decrease divided by the original amount. So here's some data I pulled off from just some open source census data. This is the population of Sumter County. Increased, that should say decreased. It decreased. I thought it would increase, turned out it decreased. It decreased from 41,017 in 2000 to 40,524 in 2010. So the city of Sumter lost almost 500 people. We're not interested in the amount of decrease over these last 10 years, but in the percent decrease. So we're going to use this formula here. We're going to find the amount, and then we're going to divide it by the original amount. So to find the amount of decrease, we can just take the bigger number, subtract the smaller number, which is fine as long as we understand that we're dealing with a decrease instead of an increase. So I'm going to take the bigger number, subtract the smaller number, and then I'm going to divide all that by the original amount, which is 41,017. So if you do this in your calculator, if I do the subtraction, I end up with 493, so almost 500, divided by 41017. And then I'll do that division in my calculator. And I get 0.012. And then some other stuff. I'm just going to round it there. So that's my percent decrease, except that number is not written as a percent. So I'm going to move that decimal over and write this as 1.2%. That's my percent decrease. So between 2000 and 2010, the population of Sumter decreased by 1.2%. There's a fun fact. I don't know if you're wondering, but interesting. We can do percent increase the same way. So here's the profits from Pretty Patty's Pancake Palace. Try saying that 5 times fast. They increased from $50,000 and $221. This is what happens when you put tongue twisters in these problems. To $62,107 this year. So this is some obvious increase. We want to find the percent increase. So we'll do the same sort of problem. We'll find the amount of increase by taking the bigger number and subtracting the smaller number, and divide it by the original amount, which would be this 50,000 from last year. Okay, so I'm just going to have to do a little bit of typing in my calculator. And I get 11886 over 50221. So that's the amount increase divided by the original amount. So if I do that division, I end up with 0.237. If I just round it like that, which is 23.7%. So there's my percent increase. Now remember, note that when I finished these problems, I ended up with decimals, which is reasonable. You change those decimals to percent, and now you have some meaningful answer, 23.7% increase. So anyway, so these are just a few examples of how these problems are, and I hope you find these problems to be really practical and functional. But they're going to require us to get used to converting decimals to percents and getting used to, in particular, this formula. This A is P% of B is pretty much a big deal, and this percent increase and decrease formula, and that should be enough to get started on some stuff.